Welcome to Calculus. We conquer our fears and flex in the face of adversity. On this episode, Stevenson will demonstrate
Now that we've looked at implicit differentiation doing first derivatives, it is possible to do second derivatives of these functions. What, Stevenson? Why would you do this to us? It's such torture. I know. So, let's talk about it. Second derivative of the implicit differentiation process. This is another flow map. Hopefully you have it written down. The good news is that it's almost identical to your first process. There's only one twist to this. So the first step is the same. You're going to differentiate everything and of the given function so you get all your dy dx's, okay, and isolate dy dx. Now, once you have dy dx isolated, step 2, you're going to do the derivative again because remember you're being asked for the second derivative. So what's going to happen in that process is you're actually going to generate dy dx terms again. So you don't ignore them though. They actually mean something. What do they mean? Step 3. This is a really important step. What you're going to do is you're going to substitute whatever that dy dx is that you found in step 1, and you're going to put it wherever there's a dy dx term in your second derivative from step 2. So it's going to turn into a little mini hot mess. Don't worry, it'll be okay. From there, you simplify as needed, and then again, like before, if necessary, you'll evaluate at a given point. But don't assume you always have to do that. You need to read the question, and the question will dictate whether or not you're plugging in numbers. Now, I'm going to give a suggestion here. Suppose you do have to do step 5, a numerical derivative, right? I wouldn't even do step 4. I would go from step 3 and skip step 4. I'd go from step 3 to step 5. Why? Step 4 is going to be potentially an algebra heavy type step. Depends on your strengths, okay? If I'm doing the step 3 and I'm doing numerical derivative, I'm going to go right to 5, plug in numbers, and then all I have to do is work with order of operations, and I don't have to worry about like combining like terms and distributive property and all that other stuff that can mess me up. So this is the process for the second derivative of implicit differentiation.